Next up, we're going to hear from Carrie Ann Brisky, who's Vice President of AI Models, Software, and Services at NVIDIA. Carrie, please welcome to the stage.
Good morning.
Thank you.
Thank you for having me. As Matt said, I'm Carrie Brisky. I head up software product management for several of NVIDIA's models, software platforms, and microservices. And it's truly an honor to be here, and I think that I'm excited to be a part of this conversation. Listening to the other presenters this morning, I think I'm not the only one who's excited, especially at a time when we are witnessing and actively participating in an incredible technological revolution. And generative AI stands at the forefront of that revolution, and it's enabled by the powerful platforms, infrastructure, and software collectively known as accelerated computing. Ooh, that was my slide that was up. So can I get my notes on the screen, please? So for over a decade now, the industry of and experimentation of artificial intelligence has seen an incredible surge in computational demands. And prior to the advent of the transformer architecture, that's the line you're looking at in blue, these early models were limited in size and both computing power. And in fact, I think Nathan had a slide up on it earlier this morning, that AlexNet model trained on ImageNet took something like 30 days trained on two PC GPUs for over 30 days. And so, however, with the introduction of the transformer architecture, marked a real paradigm shift. By harnessing unlabeled data sets, this architecture really facilitated an increase in model size and experimentation and more data, more parameters to achieve the incredible accuracy that you can see and feel with tools like ChatGPT. So this rapid expansion in model complexity also had a correspondence in the demand for computing requirements. And so to put this in context, that model at the top, that GPT mixture of experts 1.8 trillion parameter model would take something on a single Hopper GPU for our data center, something like without access to an AI supercomputer would take something like 475 years to train. So 30 days to 475 years, to kind of put that in context. And yes, transformers have been transformative, but the surge is also propelled by the evolution of these different modalities and workloads. And so initially it was, yes, computer vision, but then it quickly expanded into natural language processing and automatic speech recognition and deep recommender systems. And so then once these generative models kind of came on the scene, like diffusion models, which really stood out to leverage the statistical patterns and training data to generate audio and video and images. And then meanwhile, large language models really are tailored for a spectrum of natural language processing, like text generation, comprehension, and translation. However, the utility transcends more than mere text. And so these models are trained on domain-specific languages. So again, the language of science, the language of music, the language of software, the language of proteins. And so this enables this generation of outputs of pixels and code characters and molecular structures. And so integrating these models together and combining their modalities is termed multimodal. And so this further enhances their capabilities. And I think that we saw that last week with GPT-4o, right? So that's a real multimodal model. So generative AI wasn't new. Actually, a lot of us have been working on it for several years, but something happened in November of 2022, and I think it's kind of like the day the Earth stood still. Like, where were you? You kind of know where you were when you had that aha moment of the announcement of ChatGPT. And I think everyone realized that this isn't just any tech spike. And enterprises especially caught on to the fact that AI wasn't just computer vision, it wasn't this cool toy for cars and robots, but there was literally something that was going to change the way enterprise applications had to be built. And so, in 2023, it became the year of experimentation. And so the release of open models too, like Meta's Llama 2, or Mistral's Mixtral and Mistral models, little tongue twister, that really fueled the developer community and explored new use cases and evaluations on these use cases for their enterprise products. And so every enterprise started to discover and learn how to use these building blocks of this new digital infrastructure. And so if 2023 was the year of experimentation, 2024 is now the year of going into production. And so these enterprises are ready to kind of move generative AI from the sidelines and into their production environments. And so after they had tackled these use cases and customization and evaluations, they're now faced with new challenges. So things like latency optimizations and health checks and security scanning. So, AI used to be researchers handing like a pile of Python code and saying, here, put this into production. And IT is like, oh, I can't put this in production, but I guess I'm going to have to. But so let me just describe at a high level the way that we conceptually think about it, the components, and then I'll get into some examples and industry use cases deploying generative AI today. So customization is important to adapt these open validation models to your domain. It takes data, methodology, tools, and know-how, a foundry. I think a lot of people use this common term as a foundry for the foundation models. And then once you've customized, you need this model integrated into real-world enterprise applications. And so they can be compute intensive, like taking anywhere from 1 to 16 GPUs just to run a single inference. And so the packaging, optimization, security, they have to be addressed. And actually, once you have this model going into the enterprise application, kind of shown in the box in blue, you actually want to be filtering back the data of like what's good and what's bad to, again, customize and retrain your model. And I think we were talking about earlier, it's not just about reinforcement learning through human feedback, but it's reinforcement learning through expert feedback. And those experts are actually, it takes time because you need them doing their jobs because of the experts, but they also need to be training these models and providing feedback, and that can get expensive. Okay, here's a fun but real example of why customization is so important. So what if you want to teach a model some specialized skills that only your company would know? And so NVIDIA, for example, we design chips our own special way. We have our own proprietary language. It's called Vivid. And Vivid is a very common word for a large language model, but for us, it's a portmanteau of VLSI and NVIDIA. And it's our design code that hundreds of our engineers are using every day. And so we wanted to design a copilot to help our chip designers. And so we asked this prompt to write some Vivid code to get partitions into design. And this code that's generated looks pretty convincing. And this was done off of 2 open models. This was Llama 2 7B and Llama 2 70B. And looks pretty convincing. It's got a for loop, it's counting. But this is actually the Vivid code to get partitions in design. So very different, but more accurate. And so you may have heard that small models can match or surpass what I call gold standard models, and it's true for a particular domain. But what we've seen actually is that applying the same data to larger models provides even greater accuracy. So we're really excited about that, and I think that a lot of customers are always doing this trade-off of higher accuracy versus the compute footprint needed to actually deploy these models with latency. And so again, for latency, it all starts with the model at the heart. What we've done is we've standardized this like complicated deployment of AI models. We call it a NIM. I think that's much more fun to say than optimized model for inference and enterprise applications. And it can run next to your data, and it can be secure and optimized and latency. I mean, we've taken almost a decade of optimization. So again, so enterprises don't have to think about post-training quantization and distillation and compression of models in addition to accuracy. So we've put this all into a NIM. And we have all kinds of different NIMs. There's a NIM per model, which you'll see in a second. But so at ai.nvidia.com, it allows researchers and developers to experience these models and prototype with APIs, and also deploy NIMs into applications and systems that are solving problems. And so it's really hard as a developer to go get A, state-of-the-art models, and B, have a stable API to be able to go prototype against, and C, feel that real-time latency going through it. Oh, I guess I have to click. So let's dive into 3 areas where generative AI is being applied to particular domains or use cases. So I've brought some really great information from my colleagues in healthcare and BioNemo and weather forecasting with Modulus, so thank you, Kimberly and Nicholas. And then I'll dive into virtual agents and copilots. So healthcare, weather forecasting, and virtual agents. So drug discovery is something that has global health implications, and screening for small molecules in drug discovery faces several challenges. One, the vastness of the chemical space. I think it's something like estimated to be 10 to the 60. And the cost and time associated with experimental screening, and then the limitations of traditional methods in exploring new chemical structures. But biomolecular generative models and the computational power of GPUs help and allow scientists to efficiently explore the chemical space and to sample massive amount of structures, identify those that are promising, and then test only those. So in this example of an end-to-end generative AI virtual screening, we work with the ecosystem to curate the top models, kind of pull it into our platform. Again, we love it when our partners succeed. We like to identify top models, we like to accelerate them and pull them into our platform. So virtual screening can be achieved, the schematic here shows, with NIMs for protein structure prediction with AlphaFold, a NIM for molecular generation with MoleMan, and a NIM for molecular docking with DiffDock. Does anyone know where DiffDock came from? MIT. Okay. We can now generate unscreened candidate molecules within a matter of minutes. So researchers and application developers can really see these, visualize, and experiment. So weather forecasting, this is something that affects everyone globally, and as the Earth climate changes, AI-powered weather forecasting allows us to more accurately predict and track severe storms. Now, current AI forecast models can accurately predict the track of storms, but they're limited to a 25-kilometer resolution. So what you're looking at here is a diffusion model trained on high-resolution radar data, which means extreme events can be super resolved from 25 kilometers to 2 kilometers. So that has regional impact, and it's with 1,000x the speed. So by combining the speed and accuracy of like a forecast model and a generative AI model like this CoreDiff model, we can explore hundreds or even thousands of kilometer scale regional weather forecasts to provide a clear picture of the best, worst, and most likely impacts of the storm. This is the tracks of being able to explore the different paths, and you can see you have major regional implications. So we have this platform called Modulus. So it blends physical boundary conditions and training data to kind of build a high-fidelity deep learning model. And this really helps reimagine scientific simulations and just accelerate what we call digital twin applications. So this can democratize access to weather information and embodies this modern initiative to kind of extend climate science beyond academia. Okay. Co-pilots. So I'm going to let this sink in for a second. I'm just going to read the screen. By 2026, 50% of customer support organizations will have implemented generative AI-driven virtual assistants for agent assistance and customer-facing tasks. Why is this so exciting? If you would have asked the same question 2 years ago, I mean, I think it would be in the single digits of percents of people who were either, yes, we're looking at it, but we're not putting it at the forefront to go into production. And I know because I've been in conversational AI for like over 5 years now. And in fact, this image actually was also generated off of AI.nvidia.com with a Getty API, where we used Getty data in our structure called Edify diffusion model. Okay, I don't have a fancy video for co-pilots. It's actually not interesting to watch someone type or talk to a virtual agent. But AI co-pilots are indeed these virtual assistants to boost productivity and efficiency. And so there's healthcare co-pilots, IT help desk co-pilots, supply chain co-pilots, billing co-pilots, coding co-pilots. All of these are not made up. These are real questions from real co-pilots that are in production today with some of our partners and customers. So you can see it crosses every single domain. And I bet when you think of a co-pilot, you might think something like this. And at one point, they were ish. So it's prompt in, hit a large language model, and answer out. And it was until we realized it's frozen in time, out-of-date information, and frankly, hallucinated. So then we added what's called retrieval augmented generation. And to the large language models, you're basically embedding all your knowledge, you're putting it into a vector database, and you're retrieving information, and it goes to the LLM, the large language model, and then spits out an answer. But it's that classical problem, garbage in, garbage out. So people would just have to now learn to evaluate a system in components rather than just answer a question in and answer out. You have to start measuring what am I retrieving and why, and is it the most accurate information? So you have to break down these systems. Now, this picture is basically what people are putting into production today. However, those first movers, they're realizing that this is where they're going, agentic AI. So most queries can't be completed with one call. It needs sophisticated methods to understand, perceive, and act. So you're breaking down queries, you're rewriting the queries so the model can understand better, and this is all done with large language models. So some NIMs and large language models reason about the mission and make a plan. Some will go talk to tools and retrieve information. And so it really anticipates the needs, suggests actions, and make decisions. So, and this picture isn't even showing digital humans or personalization. So kind of think like what Jarvis is to Tony Stark. So adding that layer of personalization, it's really simple to add a digital human to the front. So this ASR, text-to-speech, speech synthesis, and just kind of putting that digital human in the front. So, but the thing is, the more you add to the system, the more you have large language models embedded in the system, which adds latency, which is why going back to that point of optimization is so important, because anytime you ask a question, it's not one LLM call, it's like at least a dozen happening. Oh, okay, there's the train there. So accelerated computing is necessary for generative models. Customization is important for domains, languages, and sovereign nations. It's not just the language of code, but the language of everybody. Inference latency is important for real-time user interaction. Generative models can be applied to every domain and every modality. Co-pilots will be and should be added to every application to amplify your work as a knowledge worker. And then second movers will be too late. And so I'll just, instead of me using my own words, I'll just say something that Jensen was talking about a couple weeks ago with Bill McDermott. Basically, when you're standing outside the train, it looks like it's going by really fast. But then when you're on the train, it's taking you and your cohorts along to the mission of where you want to go. And it doesn't seem like it's going that fast. So second movers think that they're going to reap the benefits of the first movers, and they will. But you really need to kind of get on that train and start implementing generative AI. Thank you.
Thanks, Carrie. You're great. You're fine. Have a seat. I want to start off by asking you a little bit about your experience at NVIDIA. So you've been there since 2016, I think you said, and which is on that first slide you showed. That's well in the, I think, the blue line, right?
Yep.
And now we're like far along on the green one. Can you talk to me a little bit about how things have changed in that time? And in particular, I'm wondering if, you know, there's so much demand for NVIDIA chips, for NVIDIA services now, if that has changed the way that you approach development.
Yes and no. I think that, like I said, these concepts aren't new. I think a lot of the forefront of innovation, like the Googles, the Metas of the world, we've been working in generative AI for a very long time, and it's just now that that one application really had the aha moment. I think that, again, we were working in computer vision, and we're always trying to find the next workload, what's hard, what's really hard to do. So once something becomes easy, we want to put it out to the ecosystem and allow our partners to kind of develop around it and build up around it. So we're always trying to tackle the next hardest initiative that we can find. And so that concept, that first principle, hasn't changed at all. I just think that what's different now is that enterprises, every enterprise application will now need to hit an accelerator, and that was not the case a year and a half ago. Right, so that's just the scaling is really just changed, yeah.
Let me ask you about enterprises. I mean, I know that you work with huge companies, right? But there are a lot of the demand I know comes from startups, comes from companies that are brand new. They don't have experience working in the space, or maybe they don't have experience running a company working in the space, people who are starting it. And all these big companies, I mean, they started, a couple of people. Can you talk to me about how you work with startups, how that's different than what you might do for a large, for say a Google or a Meta or an OpenAI? How is your work with startups different?
Yeah, we actually have an entire program to work with startups. I think there's something like 17,000 startups in our program, and but some of them we kind of term unicorns because they're very special and unique and they have a really great idea. And so we want to make sure that we're still seeding developer platforms and again, just putting software and models and compute in front of the people who really need it and have these innovative ideas.
How do you help them with models? Like, or is there a way that you do some specialty work with them around models?
Yeah, so I think two ways we help with models. One has always been, and again, it goes back to the beginning of my presentation, acceleration. So one, when you're training on thousands of GPUs, it's very costly, time consuming. You want to make sure that your model is converging. And so being able to have these GPUs communicate over a period of time, again, it could be many months of training a particularly large model. And so making sure that we have, it's not just at the GPU level, it's not just what we call multi-GPU interconnect, but it's multi-node. So making sure that all these systems at the whole data center scale are working together and talking together. So we help them make sure that their model's converging and everything, all the systems and software are properly working. And then when we're going into inference, I mentioned ai.nvidia.com, but we work with the world's model partners, and so who are building these models. And so when they're putting out a model, we help with optimization. So again, I talked about post-training quantization, a mixture of experts. There's a million new parallel strategies like data parallel, tensor parallel, context parallel, expert parallel. And so how are you making sure that these are small enough and communicating together across the system so that the inference latency is great.
And I want to remind folks, if you have questions in the room, please raise your hand. We will try and bring a mic to you. And if you're watching online, you can ask questions in the chat platform, and our editors will send them up here on stage. Can I talk to you about some of the specific things that you mentioned on the stage there? One was this notion of Earth 2. I love Earth 2. I think it's so cool. I'm curious, who can access that? Who gets to use it? It's not just an internal NVIDIA thing, right? Is that open to researchers? Who's able to access that data and start working on, say, AI-assisted weather forecasting?
Yeah, I actually can't speak to the data, but I would say anyone can access it. And I think the whole point, what I mentioned, is to move it beyond academia so that businesses, journalists, doing risk assessment and asset management and planning and power distribution in terms of severe storms. And so that's the point, is to democratize it. I hate to keep saying about ai.nvidia.com. You can really go out and visualize, and you see this real-time digital twin simulation happening. And so all of the things behind it are open. We make sure, again, our platforms are open so that anyone can pick them up. Anyone can pick up the modulus physics platform, right? That's open. So we try and put everything as open as possible to help developers.
I think this is the third time I've been on stage with someone from NVIDIA and asked them about Earth 2, and I could ask a million more questions. I just love it. It's so cool. We've got a question in the back of the room here.
Yeah.
Oh, well, we've got two people standing. Maybe the gentleman, then the woman in the green.
Yeah, hi, I'm Apoor from HCL Tech. It's a great presentation. You didn't touch upon the cost of deployment of AI, so if you can give a view on that. And are you seeing a trend of hyperscalers versus private AI or private cloud, or going back to the data center, right, owning the data center? So what do you think?
I'll go backwards. So I see it all. People really need hybrid deployment scenarios. So some are in cloud data centers. Some people really need to keep their data private and secure, so they're deploying on their own data centers. And then, but the beginning of the question was, what, I forget already because I went backwards. The cost. Yeah, thank you. So for, there's this, I mentioned it too, there's this trade-off of accuracy versus cost of deployment. And so when working with customers, the larger model and evaluations will give a higher amount of accuracy. And so then you put that cost to your head of how I need to deploy that and what's it cost to deploy that. But then as you start honing in on your system and retraining, you can then start to move it down to a smaller model for your domain based on the data that you've collected. And actually, we saw that happen with ServiceNow. So they originally had deployed on something like a 43 billion parameter model, and over the last year, that was last September, up until now, they're now deploying on an 8 billion parameter model. And so there is, again, there's a trade-off of cost, accuracy, and latency. And so even things like retrieval, embedding models that be able to retrieve and re-rank, we're seeing that the higher accuracy comes with these SLMs, like small language models, but they're add latency to the system. You can't do that. So we do a BERT-like model for retrieval, but then a larger model for re-ranking. But it all comes down to, it depends. And I didn't want to give you that answer, so I kind of geeked out for a second.
And then we have another question here in the green jacket. I don't know if that's an NVIDIA green jacket, but it's fantastic.
Sadly, no, but I do think we have a good color match going. Hi, I'm Sarah DeTroy. I'm with Project Evident. We work at the intersection of AI and social change. Typically, the way new technology comes into the NGO or nonprofit landscape in the US and globally is it's the most wealthy organizations or the luckiest ones that can provide the most brand halo back to a corporate entity that wants to run a contest or something like that. But you mentioned NVIDIA is really interested in the most pressing problems, right? I want to move on to the next problems. What are the ways in which technology, AI technology in particular, can come into the social sector in a way that is more equitable? So a much broader part of the sector can begin trying to apply this technology to solve some of our globe's most pressing challenges.
I'm going to say, off the top of my head, this is a Carrie answer, is data. Maybe not an NVIDIA answer, but as Carrie is what I've witnessed, is that more open data sets, more realistic data sets, more data sets that can apply to multiple use cases and global challenges. But because it does come back to what can researchers access and work on, and it has to be the data that's applicable. So
To some extent, that's what Earth 2 is doing, right?
yeah.
Yeah. Okay. Well, Carrie,
Loves
thank you.
Earth too.
Yeah. Thank you so much. Thank you so
Thank
much.
you.
I really appreciate it. That was great. Thank you.